Okay, welcome. We are looking at chapter 14, week 12 focus, and I'm just going to outline and expand on some of these ideas so that you have an example for each part that you are to know for the upcoming exam. So let's start with characteristic ions of water, OH minus and H3O plus. These are known as hydroxide and hydronium. In case you see that word, you know that they are synonyms for these chemical formulas. So this comes from when water reacts with water. So if you have a big glass of water, this is constantly going on. They react in such a way that they're continuously producing and absorbing hydronium and hydroxide. So that's what that first point means. All right, let's look at number 2, definition of acids and bases. Acids transfer H plus ions, also called protons. So that means if I have something like HCl, and let's just put it with water because that's the easiest one to look at, what will happen is that this H is transferred, this proton is transferred to water. Water becomes H3O plus, and Cl minus is left over. Okay, what about bases? Bases accept H plus ions. So this is actually another example. Water in this case is acting like a base because it is accepting this H plus ion from HCl or hydrochloric acid. Another example could be something like, let me erase this so that we have something to work with. Another example could be if I had HCl or hydrochloric acid with sodium hydroxide. So let's use this example, sodium hydroxide plus HCl. The HCl is going to donate its hydrogen to the hydroxide, and this sodium is going to pair with chloride. It's called a double displacement reaction. It's from one of our previous chapters. So what you end up with is H2O and NaCl. So in this case, the sodium hydroxide was the base because it accepted a proton. The HCl was the acid because it donated a proton. All right, let's move on. Identify conjugate acids and conjugate bases. So you're looking at pairs. An acid that acts as an acid is going to have a conjugate base pair. So for example, let's kind of shrink this down for a second. Let me do something to the right of this. Okay, so if I have NH3 in water, and water in this case is going to act like an acid, you wouldn't necessarily need to know that water would act as an acid in this case. I'm just giving you an example. So water would act as an acid, NH3 would become NH4 plus, and then water would become hydroxide. So in this case, I'm just going to use a different color. NH3 is the base because it accepted a proton. Its conjugate acid is NH4 plus. So this is the conjugate. I'm just going to abbreviate conj acid, and this is the base. And the opposite is also true as it pertains to the water. Water is the acid in this case, and hydroxide is its conjugate base. So whatever it produces on the other side is its conjugate pair, and it is now a base as opposed to an acid. If it starts as a base, then it produces a conjugate acid. If it starts as an acid, it produces a conjugate base. All right, let's move on. Let's check off number 2. We did number 3. Let's look at number 4. Identify acids and bases in a chemical equation. So we've already done that, actually. We've done a couple steps. You're always looking for what species transferred the proton. So again, in this case with water, right here, this transferred a proton to NH3. NH3 became NH4, and water became OH minus, so it just has one proton left. So that's an example of identifying acids and bases in a chemical equation. Okay, I'm going to move down actually to 6, 7, and 8. So this is my main focus for this little video, and that's because it pertains to calculations. So I want to give you an example of calculations. So let's first look at number 6. Use kW to calculate H3O plus or OH minus molarity. Okay, so let's give you an example down here. Okay, push this up. All right, so kW is a constant. So kW would be given to you. kW is equal to 1.008 times 10 to the negative 14. There is no unit associated with that. kW is also equal to an expression, and that is the concentration or molarity of H3O plus times the concentration or molarity of OH minus. So number 6 says that we need to be able to use kW to calculate either this or this, given one of the molarities. So for example, if hydronium concentration is equal to 0.10 molarity, what I can do to solve for hydroxide is simply to take this number right here and plug it in this equation. So what I would end up with is kW is equal to 0.10 times my hydroxide concentration. Then I would need to plug in my constant right here, which is 1.008 times 10 to the negative 14. So plugging that in, 1.008 times 10 to the negative 14 is equal to 0.10 molarity times the concentration of hydroxide. I would divide this over, 0.10 molarity, 0.10 molarity. Again, this really is unitless, so at this point you can really drop the unit. What I'd end up with is that hydroxide is equal to 1.008 times 10 to the negative 13. This does have a unit because it's molar concentration. It will always have the unit m. And this would be my final answer. Okay, moving on to number 7 above, which is right here. Calculate pOH from hydroxide, which is OH minus concentration. That's what the brackets mean, is concentration. And pH from H3O plus, which is hydronium concentration. Okay, so I'll give you a brief example of both of those. Let's do an example of calculating pH first. So the question might go something like this. What is the pH of a solution with an acid concentration of 0.25 molar? And specifically, it's a strong acid. Okay, so anything that I give you on the exam is going to be a strong acid, so you don't need to remember this particular point. I'm just clarifying in case you are researching online and you see that word strong. It's always going to pertain in this case to a strong acid. Okay, so I would give you an acid concentration of 0.25. That's the same thing as saying that the H3O plus, which is an acid, H3O plus concentration is 0.25 molar. Okay, the equation that would be given to you on the exam is pH is equal to negative log, this is log base 10, okay, it's a function on your calculator, even if you just have a simple scientific calculator. There will be a log button on that scientific calculator, so just make sure you identify it before the exam. Okay, so this number is just going to be inserted into the equation. So if I put that into my calculator, what I do is I press the negative button. It's usually on the bottom right-hand corner. Then I press the log button, L-O-G, not L-N, but L-O-G, log. And then I plug in 0.25, and I close the parentheses. And that gives me 0.60. Okay, so the answer would be 0.60, and it also has no units. Another example is if you had the same question, except it's asking for pOH. What is the pOH of a solution? In this case, I would give you a base concentration with and again, strong is implied, strong base concentration of, let's just say 0.125 molar. 0.125 molar. Okay, this is the same thing as saying the hydroxide concentration is equal to 0.125 molar. The equation that would be given to you, switch up the colors a little bit, would be pOH is equal to negative log of hydroxide. So it's pretty much the same formula, except you're substituting in pOH and hydroxide into what you had for the equation above. All right, so if I plug my concentration for hydroxide into my calculator, so I plug this in right here, what I would do is press negative log and then plug in 0.125, close the parentheses, and I get 0.903. 0.903. Now remember, this is a multiple choice question. Some of you might be wondering, why did I get 2 digits in the above question and 3 digits in the below question? That is dependent upon the number that I plugged in. In the above problem, I had 2 non-zero numbers I plugged in, and here I had 3 non-zero numbers I plugged in. However, you won't need to remember that for the exam since it's a multiple choice question. Okay, so let's move on to the final piece of the study guide, and that's number 8. Circle it right here. Determine acidity or basicity of a substance based on pH, pOH, hydronium, or hydroxide. So the easiest way to do this is to look at the the pH or the OH. Okay, and the general rule of thumb, not even general, the rule is that a pH of 7 is considered neutral. So anything above 7 would be considered basic. Anything with a pH above 7 is in the basic category, and anything below 7 is in the acidic category. So let's look at this number right here. pH is equal to 0.6. This number is below 7, is less than 7, so that means this is an acidic solution. Okay, now how do you use pOH to determine if a solution is basic or acidic? So it's a very similar number line, except if it is referring to pOH, 7 is still neutral, but anything above that value is going to be acidic, and anything below that value is going to be basic. So it's just the opposite. So 0 to 14, 7 is always neutral. For pOH, anything above 7 is going to be acidic, and anything below 7 is basic. So if I look at this pOH value right here, this pOH is equal to 0.903. Since this is below 7, this is a basic solution. Okay, it's a basic solution. Okay, so that is really the breadth of the information that you need for exam 3 in terms of the last week's material. Let me know if you have any questions.